So if you're planning on taking calculus, listen up, because there is one skill from precalculus that is, and I mean this, absolutely non-negotiable. It's called function composition, and really, truly mastering it, well, that's your key to the whole kingdom. So let's dive right in. And yeah, that quote you're seeing, that's not me being dramatic. This isn't just another little topic you can memorize and forget. This is the bedrock, the foundation for a massive part of calculus. I know that sounds intense, but stick with me and we're going to make this second nature for you. And this whole idea is called the chain, which is actually a perfect name because it's all about linking functions together one after the other. See, having functions inside of functions is what powers the single most important tool in calculus, something called the chain rule. You'll end up using it on something like 90% of the problems you'll ever solve. No joke. All right, so let's get right to the heart of it. What are we actually talking about when we say we're putting one function inside of another one? Well, it all comes down to a very specific sequence. Okay, so this is what it looks like on paper. That little open circle just means composed with. But the part you really want to focus on is on the right side, f of g of x. The best way to say this out loud is f of g of x. That phrasing tells you everything you need to know. G is literally inside of f. I want you to think of this like a little two-step assembly line. You start with your raw material, your input x. You feed it into the first machine, which is g. Whatever comes out of g of x, you immediately feed that directly into the second machine, f. The thing that pops out at the very end is your final answer. It's a straight-shot process. Okay, theory is one thing, but you really learn this stuff by doing it. So we're going to roll up our sleeves and work through 3 different examples, starting simple and then getting to the really important stuff. All right, let's start with a nice, straightforward problem using numbers. We've got our 2 functions, f and g, and we have an input, the number 2. The question is asking for f composed with g of 2. So, where do we start? Which function goes first? Just remember, g is on the inside. The absolute golden rule here is you always work from the inside out. So our input, 2, goes into that inner function g first. Okay, so g of 2 is just 2 plus 3, which is 5. Simple enough. Now that result, 5, becomes the brand new input for our outer function f. So we plug 5 into f, and f of 5 is 5 squared. And that's it. Our final answer is 25. See the chain? We put 2 into g, it gave us 5. We put 5 into f, and it gave us 25. The process is always the same. Inside first, then outside. Now for a really big question. Does the order you do this in even matter? Well, let's find out. Let's say f of x is x squared and g of x is x minus 2. Over on the left, we'll do f of g of x. We take g of x and plug it inside of f, which gives us x minus 2 squared. If you remember your graph transformations, that's a parabola that's been shifted 2 units to the right. Now on the right side, let's flip it. Let's do g of f of x. We take f of x and plug it inside of g. That gives us x squared minus 2. And what's that? It's a parabola shifted 2 units down. I mean, just look at those two. They are completely different graphs, not even close. You know how with multiplication, 3 times 4 is the same as 4 times 3? Well, function composition doesn't work that way. The order you do it in radically changes the outcome. It is not commutative. This is a huge point to remember. Okay, deep breaths. This next skill, this is the one. This is what that quote at the very beginning was all about. Because in calculus, you don't just put functions together. Most of the time, you're going to have to take them apart. So look at this function. Can you see the layers? Can you spot the inner function and the outer function? This is the core skill you need. Here's the secret. Just think about the order of operations. If I gave you a number for x, say x is 3, what is the very first thing your brain would calculate? You do the x squared plus 1 part first, right? Well, that's it. That's your inner function. And what would be the very last thing you do? You'd take the square root of the whole thing. That's your outer function. And just like that, we've pulled it apart. The inner function g of x is x squared plus 1, and the outer function f of x is the square root of x. And you can double check it. If you put that g back inside of f, you get exactly what we started with. This skill right here, being able to see those layers, is the real secret to crushing the chain rule. All right, so now that you know how to do it right, let me give you a heads up on the 2 most common traps people fall into. If you can spot these and avoid them, you'll be way ahead of the game. First up is simply mixing up the order.
Our brains love to read left to right, but you have to fight that urge. It is always inside out. The second one is a little sneakier, domain errors. You got to make sure the whole chain is valid. For example, your input x has to be allowed in the first function, but then the output of that first function has to be a valid input for the second one. If your outer function is a square root, you can't feed it a negative number, right? The whole chain has to work from start to finish.
So you might be thinking, okay, this is a neat little math trick, but does this stuff ever show up in the real world? And the answer is, oh, yeah. It's happening all around you, even when you're dealing with money.
So let's imagine you're sending money to a friend in Europe. This isn't just one single calculation. It's a process with at least 2 distinct steps that have to happen in a specific order.
So step 1, there's a function, we'll call it e of x, that converts your US dollars into euros. Step 2, a second function, we'll call it f of y, takes that new pile of euros and subtracts a 2% service fee. You see what's happening here? The final amount your friend gets is a composite function, f of e of x. You have to convert the currency first and then take the fee from the result. The order is everything.
So there you have it. From the absolute bedrock of calculus all the way to sending money across the ocean, the common thread is the chain. This idea of seeing things in layers, in a sequence. So the only real question left is, now that you can see the chain, are you ready to go out and use it?